In this lesson, we are going to introduce a logarithmic function. So let's talk about inverse operations first. If we have an operation of addition, like x plus 3 equals 5, what's the inverse operation? What do we have to use to solve for x? Well, we got to subtract 3, right? So subtraction is the inverse of addition. Well, what about multiplication? If we have 3 times x equals 12, what can we do to undo this? We can divide, right? So the inverse operation of multiplication is division. So division is the inverse of multiplication. Kind of the opposite. It undoes it. So what will undo squaring? Well, square root will, right? Square root will tell us what x is. Tell us that x is plus or minus 11. All right, so square rooting undoes squaring. That will tell us what the x is that we need to make this true. Well, what about this situation? What about an exponential? 10 to some power equals 100,000. Well, what is that power? Well, we're going to need something that undoes an exponential. And the thing that undoes an exponential is called a logarithm. So a logarithm will tell us that here x needs to be 5. So if we go through our powers of 10, 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000, then 10,000, and then 10 to the fifth is 100,000. So the definition of a logarithmic function is this. A logarithmic function says that if b to the y equals x is equivalent to y equals log base b of x. All right? So little vocabulary here. We call this the base, just like we called this the base. All right? So this is we're asking a question here. If we take a number to, we say b to what power equals x is what we're asking. All right, that's the same as saying y equals log base b of x. All right, so let's put some numbers to it. So this is saying that we might have 3 to the y power equals 9. All right, so we're asking a question. The question is, what is the power we can put on 3 to get 9? Or what power of 3 is needed to get 9? So this is saying what power of base b is needed to get a value of x. All right, and in this little case over here, it's obviously going to be 2, but we can rewrite this. This is the same as saying y equals the log of base 3 of 9. So we're saying, what is the power to put on 3 to get 9? That's what this means. All right. So this is going to be our key relationship here. All right. These two equations are the same. Okay. So we're going to go back and forth between these two, and all we do. So if you get that down, that's the main thing. All right. So the key is that when we're looking for a logarithm, y, we're looking for an exponent. What is the exponent that we can put on that base to get the number we're looking for? And so that logarithm finds the exponent. So that's the key. All right. So we have some logarithms here. So we want to write each equation in its equivalent form and evaluate the variable. So right now you're probably saying, what in the world is a log? You know, I like to burn logs in the fire, but and maybe you want to burn this logarithm assignment. I don't know. But a log is something that's kind of new. So let's rewrite it into something that looks more familiar. All right. So we're going to take this logarithm, and we're going to take what's kind of happening is, think about this. This b base right now is over here in the logarithm. We're going to swing it around, and then that'll become this. And we're going to have b to the y. So we're going to take that b, and we're going to put it underneath this y, and the y is the power. And then we'll have b to the y equals x. So if we have a logarithm expression, we want to change it to exponential. All right, so think about this here, all right? So 4 equals log base 2 of x. We're going to take that base, we're going to swing it around, and we're going to rewrite it. This is 2 to the 4th equals x. And now we can say that looks a little familiar now. I understand what that is. I know what 2 to the 4th is. 2 to the 4th is 16. Okay, so here we've rewritten it there. Now we've got this situation here, all right, where we've got this b base that we happen to not know. Well, we're not familiar with a logarithm, but we know we can rewrite it using this definition here, using this key relationship here. So we rewrite it, then we end up with b to the 3rd equals 125. Okay, again, we're just taking the base, swinging it around, and we have exponential form. So this base to this power equals this number. And so now that equation looks a little more familiar. B to the 3rd is 125. How do we undo that? Well, we can take the 3rd root of both sides, and we say, oh, we know what that is. The cube root of 125, well, that's 5. 5 to the 3rd power is 125. So by writing it in exponential form, it looks familiar, and we can do something with it. Now, in these last two, we had b in the base, the unknown number in the base. We had the unknown number in the x. And those became very familiar equations. But now, let's put the unknown number over on the left. So now we have a logarithm here. And we've got to understand what this statement means. So by rewriting this, we'll take the base and we'll swing it around. 2 to the y equals 16. That's what this means. This is asking a question. This is asking the same question. 2 to y equals 16. We're looking for that unknown number. Well, this probably looks a little more familiar because log is new. So look, this is saying 2 to what power equals 16? Or what is the power we can put on 2 to get 16? And if you think through your powers of 2, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16. And so we end up saying, oh, well, y must be 4. And that's right. So this is asking a question here. And we're going to want to learn to ask, we're going to want to learn to say this question. So when you look at this, it's asking the question, what power of 2 equals 16? All right? So that's the question being asked. All right? So every mathematical statement asks a question. So for example, this asks a question. The question is, what number squared equals 9? And we think through all of our squared numbers. 2 to the 2nd power? Nope. 3 to the 2nd power? Yep. That's it. All right. So we've got to understand the question that's being asked when you look at these symbols to be able to evaluate it. So we need to understand this means, what is the power we put on 2 to get 16? That's all a logarithm is asking. What is the power? So let's go ahead and change these now, going the other way. Let's write these as a logarithmic form. Okay. Now here we rewrote them and we went ahead and we evaluated them. Here, let's just rewrite them. We're not worried about evaluating them. Just going the other way now, all right? So in logarithmic form now, we're going to take the base 10, swing it around, it becomes the base. And so we're going to have the base of the log, that is, log base 10 of x is 2. So that is the log form. So how about this one? We can swing this base around. Base is b. So this is saying log base b of 64 equals 3. So those two questions, those two statements are the same equation. Just looking, it looks a little different. Now we have e. This e is this natural number that we introduced in a previous lesson. And so this is saying log base e of 23 is y. Log is or e is a number. E is about 2.71828. Okay. All right. Now we actually have a special way of writing this. This is what we call our natural log. So we'll talk more about this in a bit. But we're going to write this particular log differently. We'll write it as ln, that's a cursive L, ln of 23. When we say this as ln of 23, sometimes we put parentheses around it, and that can be helpful to realize we're putting 23 into the log. Another way to think of that. So we're taking the log of 23. All right. So that's converting back and forth between an exponential form and a logarithmic form. And that's the key connection that's going to be real important there. So to evaluate some logarithms, we can rewrite these in exponential form. So if we want to evaluate this, now this is this log base 2 of 32 is how we read that. Log base 2 of 32. This means a question. Okay, and sometimes it's helpful to put equals x on here. Okay, so we want to rewrite them in exponential form. And so we've got our key connection here. And so I'll write it again. We've got b to the y equals x is the same as saying y equals log base b of x. We want to go back and forth. Okay, if we got one form, we're going to change it to the other. So here we got base 2. If we rewrite it here, this is 2 to the x equals 32. And we can see when we rewrite it, this is asking a question. The question is, what is the power we put on 2, or what power of 2 equals 32? And we can think through our powers, 2 to the first, 2 to the second, 2 to the third. And when we get to 2 to the fifth, we'll realize that's our power. Okay, so this is asking a question. The question is, what is the power we put on 2 to get 32? So we want to start to recognize that this is just asking this question. All right, so how about this one here? Well, again, it's useful to write this equals x. And then we can rewrite it in exponential form, swing that base around, and we get 5 to the x equals 1 over 25. And again, this is asking a question. This is saying, what is the power we put on 5, or what power of 5 is 1/25th? And we can go through our powers. Well, if we think about our powers, we got to ask ourselves, all right, what makes the number drop down to the bottom? And that's going to be a negative power. So this is going to be a negative exponent. And 5 to the negative 1, we remember, is 1/5. 5 to the negative 2 will give us 1 over 5 squared. And 1 over 5 squared is 25. So the answer is x is -2. And again, the key here is to look at this and realize the question. The question is, what is the power of 5 that gives us 1/25th? Okay. One more here. You might pause it and try this if you want to practice. And make it equal to x. This is asking a question. Now, before we write this, let's practice writing the question. What is the question this is asking? Over here, this was asking what is the power we put of 5 that we use to get to 1/25th. What's the question here? Well, the question is, what power of 64 is 8? That's the question. And we'll see that when we write this in exponential form. We'll swing that base around. 64 to the x equals 8. And we got to think, well, what do we do to drop a 64 down to 8 with an exponent? Well, remember those square roots? That's the connection. Well, what power means a square roots? Well, that's talking a half power, right? So we know that 64 to the 1/2 power, that's like the square root of 64, and the square root of 64 is 8. All right, so we see that x is 1/2. 1/2 is the power you need to put in here to make this true. 1/2 is the power of 64 that will give us 8. So 1/2 is log base 64 of 8. Okay. That's the key. All right, so the logarithm is looking for the power or the exponent. Okay, and we can see that by changing it back and forth between our key relationship here. So it's all about this key relationship and understanding what question is being asked.